Alright, let's take a look at a few concavity problems like you might see on the AP exam. Here they're asking us for when is the graph concave down, so we're immediately thinking second derivative test. So let's take the first derivative. You get product rule. F is 2x and g is e to the x, so we have 2e to the x plus 2x e to the x. Derivative of e to the x is e to the x, so don't forget that one. You could simplify this, but it's fairly straightforward to take the second derivative. The derivative of this part is just 2e to the x. Now, this part is exactly the same as our original function, so it's just a repeat of the first derivative, so I'm just going to rewrite 2e to the x plus 2x e to the x, and you see that you have 2e to the x here, another 2e to the x, so you have 4 of them, and over here you get 2x e to the x. So I suppose we could factor out a e to the x, and you'd be left with 4 plus 2x. So this is the second derivative, and when does it equal to 0? That's the question. Well, this part is always positive. Recall, e to the x looks like this. Graph is always positive. So we just need to concern ourselves with this inside part here. So when does that equal 0? Set this equal to 0, you get x equals a negative 2. Alright, so if we're going to do a sign chart, we're kind of lucky here. All we're concerned with is a negative 2. So let's go to the right and pick a value like 0. E to the 0 is 1, and 4 plus 2 times 0 is 4, so we have a positive value of 4. So here, this interval is concave up. So hopefully, by default, it should be concave down to the left of this. Otherwise, we got troubles. Let's see. So pick a negative 3, let's say. You put a negative 3 here, you get a negative 6, right? Negative 6 plus 4 is negative. And when you put e to the negative 3, well, that's just equal to 1 over e to the third, which is a small positive number, but still positive nonetheless. So here we see it's concave down. So it's going to be concave down when it's less than a negative 2. Alright, so here they're basically testing you on your ability to take the derivative using the product rule, understanding the concept of the second derivative and what it means. And let's take a look at another one. Alright, so here's a table problem, and let's read the question. It says if the function's first derivative is positive, so it's always positive in this situation, I suppose, so that tells me that it's always greater than 0, meaning that this function is always increasing. And its second derivative, they tell us, is what? Negative. So when the second derivative is always negative, it is what? Concave down. Okay. So I guess we could look at this a couple ways, but let's take a look at something that's increasing and concave down. Well, this is increasing and concave up, right? So that's not fitting our situation. Let's see if we can reverse this. So if it's increasing and concave down, it has to always get bigger, but it's not getting bigger. Second derivative is decreasing, right? So something like this. So if we look at it a little bit closer, for each value, it's a little bit taller than the next one, right? It's getting taller, but it's not growing at a faster rate, so that's why we get a concave down situation here. So I only typed a couple of things here. Here you can see that this is definitely increasing from 3 to 5, from 5 to 9, from 9 to 15, and from 15 to 25. But what's the rate of change? Well, this is getting bigger by 2, by 4, by 6, and by 10. Well, that would indicate that we have a concave up situation. You could graph this out if you'd like to see, but if you do, you're going to get something like this, which is concave up. So it has to be this one over here. Let's double check it. Okay, here we have a large increase of 4, and then it's only increasing by 3 between 7 and 10. It's increasing by 2, and it's only increasing by 1. So indicating that it's rising, but it's sort of flattening out. When it's that situation, it is clearly concave down. Alright, so you have to understand what it means for something to be concave up and concave down, and then quickly apply what you know. Alright.